Hi, everybody. I was hoping that this little TikTok would be fun. I wanted to start it off with a nod to a colleague of mine. He's a former scientist that turned into a journalist. So his writing is really focused on nuclear science and technology because that's where a lot of his expertise came from. Although professionally, he was originally trained as a geologist. So he knows a lot. He's very diversified in terms of his technical portfolio. And this particular article, I think you might find of unique interest. How deadly is your electricity in terms of what is the price that you pay in terms of human lives for having this energy? And when you look, I mean, this includes things like the particulates that go into the air from fossil fuels. But when you look at the numbers, what you'll find is, for example, in the US, the numbers of death that you get per trillion kilowatt hour is going to be incredibly small. It is the smallest of all of the energy sources right there in the nuclear. So if you were to compare that with solar, where it's a little bit higher versus hydro, now it's different in the US versus other places. For example, nuclear is higher if you include Chernobyl and Fukushima. It's just in the US that it's extremely low, simply because we don't kill people with the accidents that we've had here in the United States. But even when you include Chernobyl and Fukushima, the number is still lower than all of the others. And that's just his work, which he's quite credible, but I wanted to also show you some other values that are obtained from other locations. So this is the Lancet. It's a very high profile journal talking about electrical generation and health. And I've got here one of the tables where you see again the same thing, deaths from accidents specifically, where nuclear at 0.003 versus the others that are on the order of 0.03 or 0.02, it's 10 times lower just from accidents. And then when you look at air pollution, the deaths from air pollution, nuclear is many, many orders of magnitude lower than traditional fossil fuels. And so that was pretty interesting. And then this other one that I think is maybe the most profound, and this came from the group Environmental Progress, where they were looking at the DOE's quadrennial technology review. In there, it's a table. It's a lot easier to see if you put it this way, the way that they put it together, rather than looking at the table that came from the DOE's document. But what we're seeing here is the amount of materials that are required per terawatt hour. Solar, hydro, wind, they take an enormous amount of materials to get a small amount of energy. So this ratio makes them quite high, which means it's going to take a lot of concrete, a lot of steel. For solar, you've also got to have glass, and concrete and steel take a lot of energy. And so these things, the traditional renewables, they take a lot of energy to make them. Right now, largely that's coming from fossil fuels in China. So eventually they're going to have to be renewables. We're going to have to need a lot more so they can not only replace themselves, but give electricity. Right now, they're just giving electricity because making them comes from fossil